All right, we got day 3, P4. We are going to be solving, and this is where we're going to solve with all of our methods. So it is a little bit long and a whole lot of examples, but hopefully we will refresh our memory on how to solve in each of these, because again, each of these we have done before, and we have spent extensive time in Algebra 3-4A solving these, so hopefully they're not too new for you. First thing we're going to start with are going to be squares. If you have something squared, the way to get rid of the square is to square root both sides. And when you square root both sides, you get 2 answers. This is the number one thing that is missed, is square rooting and getting 2 answers. When I solve this by adding the 5 over, I also need to simplify. So 20 is going to be 2 root 5. This is an exact answer. You will be asked for both exact answers and approximate answers. So if this is the exact. For the approximate, you would go 5 plus 2 root 5 and get, I believe, 9.47. Let me just quickly double check that. Yep. And then if you subtract 5 minus, you're going to get approximately 0.53. So those are your approximates and those are your exact answers. If you have something that is a square on both sides, star this, mark this, highlight it, because I know you're going to want to try to square both sides or square root both sides. You cannot do that. You can only do that when there's only one square on one side. You cannot square root. You must expand. Alright, so that means we're going to do x plus 5 and get x squared plus 10x plus 25. And on the other side, x plus 4 and x plus 4 is going to be x squared plus 8x plus 16. Now when I solve this, the x squares go away. And then put my x's together, I get 2x. Put my numbers, I get -9. So x is -9 halves. Again, if you're asked for that, you get -9 halves. That's one I'd prefer. Please do not put -4.5. Alright, the next option is completing the square. Completing the square was that long process that you had to do quite a bit of information on, but once you did it a few times, it wasn't too bad. What's key about that is that this A, the leading coefficient, must be 1, or else you have to divide everything by that. So if this was a 2, I'd have to divide everything by 2. If it was a 3, I'd divide everything by 3. But since it's a 1, dividing everything by 1 doesn't change anything, so that leading coefficient has to be a 1. Then what we do is we take our middle term, divide it by 2, square it. We are going to take the constant to the other side. And we're going to put this answer that we got to both sides. So x squared plus 8x plus 16. And it's always add. -14 plus 16. This is always a perfect square. It will always factor into a perfect square. That's the whole purpose of the square, is that this is going to be a perfect square. Equals 2. Now I get to square root both sides. Keeping in mind I get 2 answers. and move the 4, x is negative 4 plus or minus the square root of 2. So that's completing the square. Again, this should be refresher. You should know how to do this. If not, you're going to want to pull out some problems and you're going to want to practice them, because this is an expected skill that you have already learned and obtained from Algebra 1-2 and from Algebra 3-4. So this is the third year you're seeing it. You should definitely be already familiar and comfortable with it. All right, the next one is the quadratic formula. The quadratic formula, you should know, is opposite b plus or minus the square root of b squared minus 4ac all over 2a. And a, b, and c are the coefficients of our quadratic equation that's given. So if I say 4x squared minus 4x minus 4, a would be 4, b would be negative 4, and c would be negative 4. Plug this information into the quadratic formula. Opposite of b means positive, plus minus square root, negative 4 squared minus 4 times positive 4 times negative 4, all over 2 times 4. You will be asked to come up with exact answers as well as possible decimal answers. So when I do some simplification here, I get 4 plus or minus. This is going to be 4 times 4 times 4 times 4. This is going to give us 64. So we're going to get 16. Minus minus is plus. So 64 and the 16 is 80. We need to simplify the 80. 80 is going to be, let's see, we got 4 and 20, so it's 16 and 5. And 16 is going to give us a pair of 4s. And now we get to reduce our whole numbers. 4 reduces 8. As long as it's everywhere, you can do it. If there wasn't a 4 here, you could not reduce. It has to be everywhere or nowhere for reducing whole numbers. So we get 1 plus minus root 5 over 2. That is going to be your exact answer. If you wanted to find the decimal representation, you'd plug in your calculator 1 plus root 5 divided by 2 and get approximately 1.6, and then repeat that for 1 minus 5 divided by 2 and get approximately negative 0.6. So that's our quadratic formula. Again, it should be review. You should know this. You should know how to simplify radicals. If not, make sure you're getting in for help or getting a whole lot of practice done. Next type of solving is with a greatest common factor. Here we have 20x cubed minus 125x is 0. I can pull out a common factor of this. I can pull out the 5 and an x. When I do that, I'm going to get 4x squared and 25. This is now a difference of 2 squares, so it can keep factoring. 2x minus 5, 2x plus 5. Now each piece is going to give me a solution. 0, 5 halves, and negative 5 halves. Each piece gets set to 0 and you solve it. Greatest common factor, what do they have in common, comes out. Leftovers can still be factored. 5x gives me 0. Minus 5 halves gives me positive. Negative, this positive gives me a negative answer. I know it seems like we're kind of maybe moving through these. Pause, go back, reflect, slow down, go back over them, rewind. But these are intended to be review ways of solving and factoring. And there is the expectation that in a pre-calc class that you know how to solve and factor. All right, the next one is grouping. Grouping happens when you have 4 terms. Here's the example we're going to look at. And when we group, we start by grouping generally the first 2 together, and then we group the last 2 together, hoping to get a common term between them. So on this x cubed minus 3x squared, what's in common is x squared. What's left over is x minus 3. Well, over here, they don't share anything, but I don't have it the same as x minus 3. So I do need to take a negative 1 out so that I can get a positive x, and I can get the negative 3. Now, I have like terms, and that is the purpose of grouping, is that when you pull a GCF out of the first 2, a GCF out of the second 2, what's left over is the same. That's the whole purpose of grouping. So now, I'm going to GCF again. What's in common with the first term and the second term? Well, it's an x minus 3. If I take the x minus 3 out, what's left over? X squared. What's left over? Minus 1. X minus 3 is done, but this is a difference of 2 squares. It needs to be factored some more. If you can keep factoring, you need to. Now each piece is going to give me a solution. It's going to give me 3, it's going to give me 1, and it's going to give me negative 1. 3 x-intercepts, 3 solutions. All right, larger exponents. X to the 4th plus 5x squared minus 36 is 0. Larger exponents just means over 2, over 3. You know, we're getting 4, 5, 6. If it's even, it's just like it's a square, meaning we get to separate them into equal pieces. A 4 is even, so we're going to split it into an even piece, x2, x2. Then it's a matter of the normal factoring. What multiplies to be 36 subtracts to be positive 5. 9 and 4 will give me that. So I'm going to get positive 9 and negative 4, because that's how I'm going to get the positive 5. This cannot be factored any farther. That is done. You cannot do addition of 2 squares. However, you can do difference of 2 squares, and that's what the second one is, and I can keep going with that. This will not give me a solution. If I tried to go x squared, because remember equals 0, plus 9 is 0, I get x squared is negative 9, I get x is imaginaries, and we'll talk about them another time. Right now, it's not a solution. This one gives me nothing. This one, however, is going to give me 2 and negative 2 as my solutions. All right. The last one that we need to do by hand are square roots. If I have the square root of x minus 10 minus 4 is 0, you always want to isolate your square root so that I get x minus 10 is 4. Now to get rid of the square root, we square both sides, so we're going to get x minus 10 is 16. Move the 10, we get 26. You must check. Just like we have to check with fractions, we have to check with absolute values, we have to check with square roots. You always must check those specialties, square roots, absolute values, and fractions. You must see, does this actually work? So in this case, I get 26 minus 10 Well, that's 16, 4, 0, 0. Yes, it works. Yes, that's my solution. But you still must check it. You must check square roots, you must check absolute values, and you must check fractions every single time you solve one of those type of problems. You must check them. All right, the last thing we need to be able to do is use our calculator. All right, so here we have, pull out our calculator. Let me give you a solution here, or let's go y equals x4 minus 10x squared plus 9. All right, I could factor this. I could easily go x squared minus 9, x squared minus 1, and then go x minus 3, x plus 3, x minus 1, x plus 1, and get my x is 3, negative 3, 1, negative 1, and come up with those 4 solutions and those 4 roots. That's completely possible. However, we need to know how this works on the calculator as well. Now, we've already kind of done that, but just to kind of reiterate at it, we go to y equals. We put in the equation, so x to the 4th, use caret to get a larger exponent, 4, minus 10x squared plus 9. When I graph this, I see my picture. I see that if I were to do second, calculate, and 0, and my spider is left of one of the zeros, right of one of the zeros, and sure, enter, I would find one of my zeros. In this case, I found the 1. And I could do that 3 more times to verify my handwork, or just to find it without having to do it algebraically. So you need to know that this equation is going to give us some kind of picture that we had to give us those 4 x-intercepts that we could also find by hand, graphically, algebraically. And that will be the end of P4.